So now in this video, we have an NPN bipolar junction transistor. My body just gave this a false signal. It started turning the transistor on a little bit. But in any case, I press the button and the LED turns on instantly. Part of that is because I'm using a low enough value resistor right here where I can short it to the positive supply. But the main thing is when I release the button can even fly out of the board if it wants to. The circuit just keeps going. So these switches, I could like file this down or something, it would fit into the board better. But since anybody else getting one of these will probably have the same like problem with it working in the board, I figure I would just leave it. Sometimes it stays in really well. Other times it goes flying like you see there. But in any case, I press it and that charges the capacitor instantly. And after I release it, there's going to be a period of time where the capacitor can probably keep the transistor on fully, but then it starts fading down. So the on fully is saturated. Covered this in the last video too. I obviously just copied and pasted this. But yeah, fully on is saturated. As the LED is dimming down, it's in the active region. And once it's off completely, there's no current flowing at all. There's cutoff. And, you know, the voltage goes down quicker at first and then slower over time. So it'd be kind of hard to tell when exactly cutoff would be. And again, you could use a larger value capacitor or a base resistor that's larger so that the timing takes longer. You know, the may not be fully on for as long though. And yeah, you got to prevent the power rating exceeding the power rating or current rating of any component, of course. So you can't go too low in value and stuff. And you know, larger value capacitors at much higher voltages than 12 volts probably, you know, you'd want a little bit of resistance along the way. And we have a symbol here for taking a voltage measurement. You can look at it going down, but it's an RC time constant curve. It's nothing too exciting. And so yeah, I did this with 5 volts. Since it's off, I can go up to 15 and then lower it to 12. And because you can see no current flowed while I did that. And we'll scoot this over. We can look at how much current is flowing when I press this. So LED drops about 2 volts. We can expect once I close the switch that there is about 10 milliamps of current approximately. There's a little bit more current because of the base current flowing right there. So we're getting about as much current as we can expect. And there where I released it, when it was holding steady, that should have been the transistor saturated. And then you can see how quickly it went down with the current there. And so yeah, this voltage was dropping quickly. And so we don't need to actually take a measurement of that. And we can look at what we get for 5 volts as well. And so I'm using a 1000 ohm resistor to protect the LED. And for each volt across it, you'll get about a milliamp of current. Red LED drops about 2 volts. We can expect about 3 milliamps of current, which is what looks like we're getting there. And somehow I bumped it up to 4 a little bit. But there you can see it held 3 for a while. It's not going to drop as quick because we got less current flowing. And, you know, so we don't have as quick of an initial drop. It goes slower over time as the voltage gets lower. But, you know, there you can see about 0. But we still got some glow. There's a little bit of current leaking through. So, yeah, we showed that. Also, sometimes I use like 12 volts in my circuits. That's why I have current limited to 20 milliamps of current in case I forget to go from 12 volts to 5 volts. The current will be limited, so voltage won't rise above a dangerous level. Red LEDs can handle up to about 20 milliamps of current, and usually other components are even weaker. It lowers the voltage as needed to prevent overcurrent from happening. And yeah, we have it as a switch again. That's if you want to take a voltage measurement. I don't see much point right now. And you can, you know, if you're just using 5 volts, use a 220 ohm resistor. The red LED will be brighter when it is on fully. So there's the pin layout for the 2N3904, which I'm using. But just because it says 2N3904 doesn't mean you have to use it. You could use like the C945 or 2N2222 if you want. 2N2222 has the same pin layout if it's bipolar junction transistor and starts with 2N. it should have the same pin layout. All the ones I've come across so far have. But if it's a different number, then good chance it has a different pin layout. So be aware of that. But yeah, we got emitter to the left, which is bottom, base in the middle, and then collector to the right or on top. And so when I turn this to the right, we have that emitter, base, collector. If I turned it around, the emitter would be up there. I'd have to rewire everything for the opposite directions. You know, we'd have to put the resistor to the positive and then the LED coming up, swivel the LED around and connect that to ground. So normally you work your way positive up on top, down towards negative. So I got that there. But you could rewire it to work your way up, or yeah, up from positive at the bottom up to negative if you wanted to. And again, these switches tend to bounce out. Probably want to like file it down or whatever, bend them. So they fit better, whatever you gotta do. But again, I don't do that for my videos. Just as a reminder that especially when they're new and you got a higher quality board, they tend to, you know, have like stiffer metal. It like pops it out. Whereas the cheap ones, like this breadboard, I may have never, I accidentally screwed up solder, may have never stuck a component there. So the switch won't go in the wrong way unless you really forced it to. It you know, lines up, you know, decently well there, and yeah, there we go. It probably you know, was soft enough metal where it kind of bent into the shape to hold it. It's not squeezing it as hard. It went right in. I may never have put any components into those spots right there. Whereas this board, especially when it was new, it really rejected these switches. It's doing a lot better now than it did, but it's still, after all these years, is still making it pop out, sometimes more than others. But in case, I guess we can do a little more. Using 100 microfarad right here, and you know, like 1,000 microfarad, you might not want to short 5 volts, but probably 5 volts is still okay. And you know, we could add some resistance. That probably wouldn't be too bad of an idea. And I'm using a 10,000 ohm resistor right there. Again, it's adjustable depending if you want to go faster or slower, but you know, you are limited with how much current you can provide. So higher value ones, you probably won't be able to saturate the transistor, especially right when you let go of the button. So that's something to be aware of. But in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.